Good morning, all of you. The summer research training program students are lucky to have a doyen in the field of geoscience, Professor Harsh K. Gupta. Today, he is giving a talk, and he is probably one of the most celebrated scientists of our country. Have so many offers. Padma Shri was conferred on him, and he is currently the member of Atomic Energy Regulatory Board and president of Geological Society of India and past president of International Union of Geodesy and Geophysics. And he is associated with NGRA Hyderabad and also all the activities that to do with geology that are going on in our country. And at CSIR East or RRL Jorhat, we are privileged to have Professor Gupta as our Chairman of Research Council for several years. Under his able guidance, RRL has grown immensely, and more importantly, the gentleness with which he guides, mentors people, the affection and everything is responsible for us to be motivated to work towards it, to do our best. Sir, on behalf of CSIR NIS, we thank you very much for accepting our invitation. I invite my colleague, Dr. V.M. Tiwari, to introduce Professor Harsh K. Gupta. Dr. Tiwari.
Namaskar, sir, and very good morning to all of you, Professor Gupta, Professor Narhar Shastri, and colleagues who are organizing this mega event for the young generation of the researchers, and my dear students who are joining this program today through the webcasting. I am honored to have the privilege to introduce distinguished speaker today in SRTP. I am elated to introduce Professor Gupta to each one of you, and you may be knowing, as Professor Narhari Shastri said, he is a man of distinction and living inspiration to all geoscience fraternity, particularly to India. I have known Professor Gupta since the early days of my career as a student, subsequently as a scientist, and we had a privilege of also working under his direction for several national and international programs led by either by him or the institute, CSIR National Geophysical Research Institute at Hyderabad. Professor Gupta is really very different person who had been holding the senior administrative scientific positions at very early age of his life and still had never left science behind. He had always been in forefront of the science. In very early age of his life, he was director of Center for Earth Science Studies at Trivandrum, which he had built from scratch. And that's the one reason he is often known as an institution builder. So he had been instrumental in starting several new programs. He was the person responsible for building Indian scientific station in Antarctica in a record time, which still remains globally record. So the Indian flags are high in Antarctica through the contributions of like Professor Gupta by establishing the institution in the Antarctica and also supporting the science of the Antarctica. He held the position of Vice Chancellor of Cochin University of Science and Technology, and also he had been instrumental in creating DRDO Cochin University of Science and Technology Computer Center. There are several institutions and the scientific programs which were built, directed, and mentored by Professor Gupta nationally and internationally. As Professor Narhar Sastry said, he held the bureau membership, vice presidency, and the presidency of the International Association of Geodesy and Geophysics, the only Indian in the so who has led such kind of the distinction. He is currently the Nasi Platinum Jubilee scientist at CSIR National Geophysical Research Institute, and also he is member of Atomic Energy Regulatory Board India, a very distinct position for driving the decisions making related to the atomic energy. He is also president of the oldest geological society of the country, Geological Society of India. Professor Gupta is also globally known for artificial water reservoir triggered earthquakes, hypothesis generation, and demonstration that how the knowledge of the triggered seismicity can help in decision making of the reservoirs and monitoring of the reservoirs, which are essentials for the development, for the generation of the electricity, as our requirements of the electricity is increasing day by day. You all may be knowing that at very young age, he wrote a book on dams and earthquakes, which had been translated into Russian and Chinese. And 2011, he compiled the Encyclopedia of Solid Earth Geophysics. He also held the position of member disaster development authority, management authority, and which is equivalent to the position of minister, union minister of states. He is a recipient of prestigious Shanti Swarup Bhatnagar Prize, also recipient of Waldo Smith Medal of American Geophysical Union, which is probably the highest honor the geoscience community people receive for creation and the development of the scientific institutions and science. He also been awarded by other countries like USSR Academy of Sciences with the 100 years of the International Geophysics Memorial Medal, Expert Medal from the Asia Oceania Geoscience Society, and several other honors and awards from Government of India, from Ministry of Mines, from Ministry of Earth Sciences. He is fellow of the Distinguished Academies of India, and most importantly, he also been the founder president of Asian Seismological Commission, which directly connects to the earthquake studies, particularly to the Asian region. So with this big background, I feel honored and very much privileged to present before all of you our past director, Professor Harsh K. Gupta, to give a talk which is very contemporary. That itself shows that how deep his involvement is with science, that he chose to speak on a very topical issue, the present day seismicity near and around Delhi. With this, I would also like to thank from all the scientific, geoscientific fraternity, and particularly from the CSIR, to thank him for accepting our invitation and delivering today's lecture. So thank you, Professor Narhar Sastry. It's over to you.
Thank you, sir. Thank you, Professor Tiwari, and thank you, sir. Please, now it is for Professor Harsh Gupta to continue his talk.
A very good morning to all of you. It's such a pleasure to be with you this morning and talk about recent earthquakes in the vicinity of Delhi. And let me also take a minute to thank Dr. Narihari Shastri Garu, who very kindly invited me to give this talk, and Dr. Tiwari, who has been very supportive for all the work that I have done all these years. Now, let me also tell you that I have picked up this topic so that I can show that how misinformation is spread all over and how little we know about the things. At the same time, specifically, since this is being organized by NEAST, NEAST is located in one of the most earthquake-prone regions, and it has done wonderful work, which you will see in time to come in my talk. So the slide is not moving. Hello, can you hear me?
Yes, sir.
The slide is not moving from here now.
Sir, press Windows D button and go back to your PPT. Then you.
We checked it, it was working fine. Okay, we go back. Live slides, okay.
You can close that, sir. Yes, click here.
Sir, stop sharing and again share.
Yes, sir. Done. It's unshared. Now you can select this, sir. Anyone to share.
Can you see it now? But this is
Yes, sir.
Yes, it's fine,
okay.
sir.
Okay. So you see, in the month of April to June of 2020, there were several earthquakes in the vicinity of Delhi, and the largest of them was about 4.5 on 29th of May. And this led to a flurry of news in the media and speculation all over that these are probably precursor to a very major earthquake, and people have been talking of a large earthquake for a long time. This was one view. At the same time, some people came up with the idea that since these small little earthquakes have occurred, maybe they have taken out the energy of a big earthquake and we may not have a big earthquake. But this is not the first time that such earthquakes have occurred in and around Delhi. During the period of 1960 to 65, there were about 300 shocks of magnitude 1 and larger in an area of about 12,000 square kilometer within 100 kilometers of Delhi. And the largest of them was of magnitude 4.5. And there were several earthquakes of magnitude 3 which were felt. So this is not the first time. If you go historically, the largest earthquake to have occurred close to Delhi is the 1720 earthquake of magnitude 6.5, Mathura earthquake of 1803. So you can see that several earthquakes have occurred in and close to Delhi. However, after the 1956 earthquake, there has been no earthquake of magnitude 6 or larger near Delhi. So I got the data from India Meteorological Department, and this table is a little complicated. It shows all the earthquakes that occurred in an area bound by 26 degrees to 30 degrees north and 75 degrees to 79 degrees east within the area of Delhi from the earliest period to July of 220. And another important thing is this table is that in the extreme right, the distance in kilometer is given from India Gate. So I have just highlighted earthquakes which occurred close to it. So for example, the 720 earthquake was just 29 kilometers away. Then the 1960 earthquake was 27 kilometers away. Then again, 1994, 15 kilometers away. And the 2007 earthquake was 13 kilometers away. So it is not that earthquakes have not occurred in Delhi in the past. Now, very often I am focusing a little more on the younger students because very often we talk of earthquake without realizing what an earthquake is, what the magnitude are, what is the frequency. So this is a general way of looking at earthquakes and their frequency globally. So the earthquakes which have a magnitude of 8 or larger, they are called great earthquakes, and usually you have only one every year. Then there are major earthquakes, 7 to 7.5 magnitude, and they are more often almost one every month or 18 every year. When we go to smaller earthquakes, say for example, moderate 5 to 5.9, there is a mistake here, 6 to 6.9, this is I think 180 or something like that. Moderate earthquakes 5 to 5.9, they are 800. And when we come to very small earthquakes, like what has happened in Delhi between 3 and above, there are 49,000 earthquakes every year. So every day there are 100 such earthquakes taking place. So what is happening in Delhi is not very rare. We must also realize that earthquake magnitude scale is a logarithmic scale. And when the magnitude goes up by 1, the energy release goes up by 31 times. At the same time, in a common man's language, a magnitude 6 earthquake releases energy equivalent to an atomic bomb like Hiroshima, Nagasaki of 1940s. So from 6 to 7, there'll be 30 bombs, 7 to 8, 30 into 30, 900, and 8 to 9, 30 into 30. So the number keeps on increasing. So when we talk the very great earthquakes, like the Sumatra earthquake on 26th of December 2004, or the Fukushima earthquake of 11th March 2011, they release energy equivalent to some 30,000 of Hiroshima kind of bomb. Earthquakes of magnitude 3 are locally felt, and when we go to earthquakes of magnitude 5, they can be damaging. And if an earthquake of magnitude 6 occurs in an urban area, it could be very, very disastrous. Just to talk of the 26th December earthquake, this is the largest earthquake of the 21st century so far, and with a magnitude of MW 9.2, the earthquake kept on rupturing for 500 seconds. The total rupture length was close to 1500 kilometers, and the vertical displacement was up to 20 meters. So you can imagine how big these earthquakes can be. The saddest part is that in spite of all the scientific and technological developments, we have not been able to contain the damage of earthquakes. For example, we are now in the 20th year of the 21st century, and in the past 19 years of 21st century, we have lost more human lives and financial losses have far exceeded than the entire similar loss from earthquakes and tsunamis in the 20th century. So somehow the work that we do, scientific, technical, social, it is not making an impact. So that is one of the issues which we should be all sensitive to, and especially the people who live in earthquake-prone zone like zone 4 and 5, and Jorhat is in zone 4, they have to be careful. Now let us look at the 21st century's most devastating earthquakes. So the 26th December earthquake killed about 300,000 people. Then Muzaffarabad earthquake, and like there are about 6 or 7 of these earthquakes. I have colored the 3 earthquakes because all 3 of them affected India. The Sumatra earthquake had killed close to 18,000 people in India. Muzaffarabad earthquake was on the border of India and Pakistan, and there also we lost close to 1,000 people in Kashmir. And then similarly, the Nepal earthquake had affected parts of Bihar and other areas, and we lost many human lives. So if you look at the 9 most devastating earthquakes of the 21st century, 3 of them had affected us. At the same time, we have to look into that in what way, in which direction we are moving. So if you look at the largest cities in the world, 7 of these largest cities in the world are in Asia. And out of these 7, India, then in Delhi, then we have got Mumbai and Kolkata are the 3 among the 10 largest cities of the world and 3 among the 7 largest cities of Asia. This also I like to share because we should be sensitive that what exactly is happening. The people killed by natural disasters, if you look regionally, Asia accounts for 68% of them. Europe 6%, Oceania 7%, Africa 6% again, America 11%. Again, there is a typographic. Europe is 6.856, not the one what is showing there. And at the same time, the urbanization is growing fastest in Asia. In 1950, about 17% of our people were in urban area, which increased to 46 in 2012, and is expected to go to 55% by the end of 2030. So we will have more people in urban areas. So what is very important is to bring in the concept of disaster risk reduction in urban development. And the target is to make our projects disaster free. Now let me come to Himalayan region. Himalaya has been seismically one of the most active regions in the world. And in this region, we had 4 great earthquakes. The 1897 Shillong earthquake, about which we'll talk a little bit more. Then we had the 1905 Kangra earthquake. Then we had the 1934 Bihar Nepal earthquake and 1950 Assam earthquake. No earthquake of such a magnitude has occurred since 1950. In the recent past, we have had the Assam earthquake in 1988, which was of magnitude 7.3. Then we had on the west the Muzaffarabad earthquake of magnitude 7.6 in 2005, and just 5 years ago we had the Gurkha earthquake in Nepal in 2015. We examined that this paucity of large earthquakes, how real it is. So there was analysis carried out in 1996, where we have now updated it to the current level. So if you look that from 1897 to 1952, there were 14 earthquakes of magnitude greater than 7.5 or equal to 7.5. And from 1953 till now, only 3 of them. When you look of magnitude 7, they become comparable, and 6.5 is as you would expect. So there is really a dearth of magnitude 7.5 or larger earthquakes in the region, and we thought that this may be due to overestimation of magnitudes in the earlier time. So we very meticulously went through all the old records of Göttingen laboratory in Germany and redetermined magnitudes of all the earthquakes, and we found that they were within error limits of quarter of a magnitude. So this paucity of a mega earthquake is real. Now, as I told you, that earthquakes cannot be forecasted as of now. Also, when people say that these are foreshocks, we get to know that the foreshock is a foreshock after the main shock has occurred. Damaging earthquakes have occurred in the Himalaya. No such earthquake has occurred since 1951, and there is a paucity of 7.5 and large earthquake. As of now, we don't know when and where such an earthquake will occur. Okay, suppose we get to know that there will be a magnitude 6.5 earthquake in Delhi day after tomorrow at 11 p.m. Can everyone leave Delhi? No. So we have to basically learn to live with earthquakes and develop an earthquake resilient society. That becomes the most important issue for urban development, particularly in the Himalayan region. Now, there are many examples that how earthquake resilient societies have performed much better during earthquakes than the areas which were not prepared for that. The 2010 Haiti earthquake, it was only of magnitude 7, but it claimed close to 300,000 lives. Somewhere in 1990s, I was on a mission supported by the Commonwealth Science Council to look into Caribbean countries about their vulnerability, and that report is very much there, which told very clearly that there is no preparedness for such earthquakes. And of course, this is exactly what happened. Now look at the Fukushima earthquake, which was of magnitude 9, and it killed only 18,000 people, and it was 900 times bigger than the Haiti earthquake. So by making an effort, this can be achieved. The similar things have happened in Taiwan, have happened in Mexico, and many other cities. So it is not that Japan is a high-tech country, so they can do it. It has happened in much less technically advanced countries also. So that is something we should aim at. So with this as a aim, the National Disaster Management Authority took up an exercise of preparing a scenario that if one of the earlier earthquakes repeats, what would happen? And we took the help of IIT Bombay and in preparing two cases, that was 1905 Kangra earthquake in 1897 Shillong earthquake. The picture of the Kangra earthquake of 1905, magnitude around 7.8 or 8, and it killed 20,000 people. So we started this work by preparing a scenario, and this scenario was developed by taking a magnitude 8 earthquake, which will have a rupture of about 200 kilometers, and we centered it at Mandi. And you can see around it isoseismos. The dark isoseismos are intensity 9 to 10, the lighter 8, like that. So you see a huge area would have such huge intensity. Now on this scenario, if you put the layer of the typology of the houses, you get to know how many houses would be destroyed. On that, if you put the layer of the population density, then you get to know that how many people are likely to get killed. And this is exactly what we found. We considered only 4 states, Himachal Pradesh, Haryana, Punjab, and Union Territory of Chandigarh, and we found a staggering figure that some 9,93,000 human lives would be lost if this earthquake occurred in the mid of the night. I was a little worried about this result because it appeared too long. But then soon after that, there was a Bilton Park meeting in UK. Bilton Park meetings are meetings where they take up a specific topic and they invite some 15-20 people. And they have a 3-day-long session. So everyone is free to talk for whatever length one wishes to talk, but they try to thresh out issues. I was invited there to talk about tsunamis. However, there was a professor who showed the areas where 1 million lives would be lost in case of a natural disaster, and the entire Himalayan region was red. Showed that it could occur anywhere, a magnitude 8 earthquake, and it would claim that many lives. Our estimates of 0.9 lakh was only from 4 states. We did not include other states like Uttar Pradesh, which would also be affected. Now you take the case of the 8th October Muzaffarabad earthquake, which occurred on India-Pakistan border. It had a magnitude 7.6. So 7.6 is almost 10-12 times smaller than a magnitude 8 earthquake as far as energy release is concerned. And it occurred at 9 o'clock in the morning when almost everyone is out of the house. And we lost 80,000 lives. Suppose this earthquake had occurred in the middle of the night, the number would have been just doubled. And suppose the magnitude was 8, then you don't know what would happen. You take the case of Latur earthquake in 1993, only a magnitude 6.2 earthquake. It occurred in the middle of the night and it killed 10,000 people. It became one of the deadliest earthquakes. So there's a very old saying that it is not the earthquakes, but the houses that kill people. And that's why in places like Assam, people earlier were very clever. They will make very light roofs and bamboo roofs so that even if the house collapses, not much damage was done. So we took up this building of the scenario, and then the idea was to see the consequence of a large earthquake and then facilitate mainstreaming earthquake risk management in state governments. And state governments should be aware that what they have to do. And this was almost a year-long exercise where various aspects were taken. I'll just mention a couple of them. Now, schools are a very sensitive place because we have seen in Sichuan earthquake in 2008, 20,000 children were killed in the schools. In Muzaffarabad earthquake in Pakistan, 16,000. In our own case in Bhuj, we lost some 900 lives of the children. So the first and the most important thing is that school children should learn what to do during an earthquake. We all say that go to a safer place. So when the earthquakes start occurring and you get the first feel of it, you cannot think at that time that where we should go. So we must think ahead of time. Most of us will be spending time either at our workplace, whether it is office or school or whatever, at our home, and we might be in market, etc., etc. So we must think ahead of time that during an earthquake, if I'm at my home, am I safe to get out in the open space? If I stay in a multi-story building, 10-story building, I'm on 8th floor, then I cannot get out. So I should find the safe places in my own flat. Like this, we have to be prepared for such an eventuality. The other important issue is the safety of the lifeline buildings. So lifeline buildings are things like hospitals, like fire stations, like police stations. And on 26th of January, when we had the Bhuj earthquake, several hospitals got damaged. And there is a scheme, there is a technique called the rapid visual screening. This scheme permits a qualified engineer to have a look at the building, then see the structural map of the building and estimate whether this building can withstand the estimated accelerations during an earthquake in the region. And then we talk about either we try to retrofit this building so it is all right. And if the retrofitting cost comes to 60% of the original cost, then we suggest that it should be rebuilt because there's no point of spending so much of money. So it becomes very important issue that all the lifeline buildings should be able to withstand the losses. So this was taken up, and we have taken up for the 4 states, Himachal Pradesh, Punjab, Haryana, and Union Territory of Chandigarh. there was a year-long campaign, and we had taken very well-known mascots like Kapil Dev, Yuvraj Singh, and there was a total training of the people around the year, what they should do, what is the preparation of the hospitals, what is the preparation of the schools, what is the preparation of fire department, etc. So all this exercise was conducted for a year's time. And then a mega mock drill was scheduled on 13th of February 2013, where at 11:30 the earthquake took place, the virtual earthquake took place. And we had paid some 300 points in these 4 states to observe how people behave. And these are some of the pictures, Shimla, Mohali, etc., etc. And then there was a debriefing next day. All the district administrators told what they saw, the National Disaster Response Force, the State Disaster Response Force, the Army observers, and there was a very wide coverage in the press, which pointed out all the shortcomings. And that was the main purpose of this exercise, that people should get to know what are the shortcomings. And I saw an immediate effect of this, because after this exercise, I was sitting in my office in NDMA, which is in Sabdajan, and I felt a tremor. And obviously I came out. When I came out, I found that almost everyone from the nearby houses was on the road, because this has happened just before we had done this exercise. So that makes it important that this kind of exercises should be repeated annually. Say, for example, for the Shillong region, you can take up the date of the Shillong earthquake, of Assam earthquake of 15th August, or some other earthquake, and make a habit to repeat it every year. So the positive outcome of this exercise was sensitization of the state administration, hands-on experience, awareness generation, and gaps identified. And the best part was with the students. They were so enthusiastic about it that I used to go to the schools to tell them about it, and at times the hall would not be able to accommodate all the students, and they did not have a proper public address system, so all of them could come. So in those cases, there'll be repeat of those lectures, and students would like to listen to that. Let me now tell about the 1897 Shillong earthquake, which is very close to Jorhat. It had a magnitude of 8.7, occurred on 12th of June. Now look at it. The death toll was only 1,500, because at that time Shillong was very scantily populated. All of that region was very scantily populated, although it was felt over a very large area. This was the first earthquake which provided an evidence that acceleration due to an earthquake can exceed 1 G, because boulders came out of their socket in the mesoseismal area. This is a picture of the bridge across the Shillong Lake. On the left hand side, it is all right, then you see all flattened. Down below is the All Saints Church before on the left side, and what happened to it after the earthquake. And Northeast India is unique because we had almost 10 earthquakes of magnitude 7.5 and larger in the past, and nothing has happened since 1952. And globally, it is one of the 6 most seismically active regions in the world. I must also tell you that the August 15, 1950 earthquake is considered to be the largest on-land earthquake anywhere in the world ever recorded. These are the isoseismals of Oldham. Oldham was at that time the Director General of Geological Survey of India, and he spent several months visiting all these places and preparing a map to show the isoseismals. So we did the same exercise here again. And on these isoseismals, we placed the typology of the houses. And on the typology houses, we put the population density. And we found that if this earthquake occurred in the middle of the night, the lives lost in Assam would be 600,000. Manipur, 38,000. Meghalaya, 68,000. Nagaland, 30,000. Sikkim, like that. and total again comes to a huge number. Now, this was one of the beautiful exercises where we had the total cooperation of all the northeast states, 8 northeast states. And this responsibility was very heavily shared by CSIR and East. They took the responsibility of propagating the messages, conducting the exercises, and of course, there was a National Disaster Management Authority. And then we picked up the mega mock drills as we had done for the Kangra earthquake of 1905. Only since we were talking of the 8 states, we could not do it on single day. So we broke it up on 2 days, 10th March 2014 and 13th March 2014. And these are the states where we did it, and everything went according to the plan. And then I am sharing the action at Military Hospital in Shillong, Mizoram SDRF ready for action. And this again created an immense response and did bring out the shortcomings in our work and what we need to do. In conclusion, I would like to state that once again, that as of now, we are not in a position to recognize whether a shock is a foreshock in real time. And as I said earlier, that even if we recognize that an earthquake is going to occur, we cannot leave the place, all of us. So it is important. Then it is a fact that there's a paucity of 7.5 magnitude earthquake in Himalaya. It can occur any day. When it will occur, where it will occur is not known. So the solution is to develop earthquake resilient society. And conducting of the mega mock drills, the way we did it, is extremely helpful. And these mega mock drills should be, there should be alert exercises every year, especially awareness campaigns should be repeated. And school students become the key to be addressed, because if a school child, 10, 14, 15-year-old boy or a girl becomes cautious about it, the first thing he or she will do is check whether his or her home is okay. And then you have trained a citizen for the rest of the life. And I very strongly feel that institutes like Northeast Institute of Science and Technology have a very major role to play, because it has shown that what difference it can make to the life of the people. And I'm sure there are many other institutions like that and in the entire Himalayan belt and other places who have to take this responsibility. The last point that I wish to make is about the importance of earth sciences. You see, I've been an earth scientist, and it has been a very pleasant journey all this life. And in one of the award ceremony, somebody asked me that, Professor Gupta, if you have a chance, what else would you like to do? And I had not prepared for that answer, but my immediate response was that not a day should be different than what it has been so far. I'm so happy and satisfied with whatever little I've been able to do. The advantage of an earth scientist is that you discover new things every day, because Earth is not the same at every place. It changes from place to place. It changes from time to time. So if there is a curiosity, then it is a wonderful place to work upon. And also you see, in the 21st century, when very survival of planet Earth is being questioned, we are talking of heat waves, we are talking of temperature rise, we are talking of all kinds of things. So it is very important that we understand how this planet works, and that the key to that is having proper understanding of our sciences. Well, it has been a pleasure talking to you. I have taken a little longer than what I had planned. I hope you can live with it.
Thank you very much, sir. It was wonderful to listen to you. And I am requesting my colleague, Dr. Saurav Borua, to take this forward. And sir, will it be possible for you to take some question answers?
I'll be happy to do that.
Okay, sir. After Dr. Saurav Borua, our young students, they will be putting some questions, and I am now handing over to Dr. Saurav Borua.
Thank you, Professor Sastry. We have just heard a wonderful lecture by Doyen of Seismology of India, and if I'm not wrong, world, who has contributed many ways to Indian seismological scenario. And what I have seen in his lectures, he has given the entire overview of the entire gamut of earthquake seismology, right from its occurrence, how we have to live with earthquake, and what we should do. That way, he has touched upon two major earthquakes of Kangra earthquake and the 1897 Shillong earthquake. My dear students, it's a wonderful opportunity for us to listen to Professor Gupta, who has said we have to live with earthquake. We have to live with earthquake means we have to develop earthquake resilient society. And as you have heard, Professor Virendra Kumar Tiwari has said that he is the first leader to Antarctica who has established the Maitri Antarctic Observatory in a very short span of time. Simultaneously, another point I would just like to mention about Professor Gupta, that he started his career in northeastern region of India in Shillong. And if I remember correctly, sir, your mentor was during that time Professor Haripada Saha, whom you always honor in your lectures. Vishnupada Saha. Yes, sir. Vishnupada Saha. So, my dear students, you have heard of him, and he has said where to go. So we have to live with earthquake. To live with earthquake, we have to develop two things. We have to develop earthquake resilient society, and to live with earthquake, we have to develop one more thing. That means we have to have some mock practice always in our life. So apart from that, he has also mentioned that earth science is the importance of earth science. So science must be and continued to overcome the situation and to build a earthquake resilient society in the near future. So with that, I over to SRTP team and also to the students to put forward your questions so that sir will be very happy to answer those questions. Thank you.
Thank you so much, sir. And thank you, Harshke Gupta, sir, for enlightening us with your informative lecture. As Northeast region is prone to earthquakes, we thank you, sir, again for giving us such an in-depth knowledge on this natural calamity. Sir, if you would permit, then we would go forward with the questions. So should we?
Yeah.
Thank you, sir. So the first question is from Divyata. As we know from the lecture itself, the earthquake releases energy equivalent to bombs that were used in 1940s. Can we obtain and convert this energy into something useful?
An excellent question. And since we do not know exactly at what depth this energy is being stored, and there is also a question that when you try to tinker with that source, you may trigger it. So a lot of exercises have been done not to use that energy, but to try to diffuse earthquakes by releasing small little triggers. But finally, it was thought that it is not wise to do that. But there is another form of this energy which people have thought of using, and that comes through volcanoes. Because volcano emit lava, which has huge temperature, thermal energy, and people have thought about the plants. but no practical thing has happened so far.
Sir, the next question is from Pinaki sir. Is it possible to make a minimum design requirement to be satisfied in mandatory way for common households to make them safe and earthquakes resilient?
A very good question, and I very strongly suggest that we try to encourage as far as possible the traditional kind of houses which are so popular all over Northeast. These traditional houses are excellent because they use very light material. They use bamboos and things like that, and roofs are not very heavy. So I think that is something which I would like to encourage. If you have to go for a multi-story building, there is nothing wrong in trying to make an earthquake-proof multi-story building. I give you a very simple example. In the 1934 Nepal earthquake, a lot of damage was due to soil liquefaction. So soil liquefaction means that when the earthquake shakes a region, then there's a lot of fluid within the pores of the shallow earth, and that comes out and the soil loses its strength, and it becomes like a jelly. So a house which is depending on staying on this jelly, this strength, will collapse. So the way out is that wherever we are planning to put up a tall building, we try to find out how thick is the soil liquefaction layer. That is easily understandable. There are methods which tell you. Then you take the foundation of that building deeper than that. In Japan, you will find houses which are 16 stories, 20 stories, and then there are 10 stories down below. So this is one typical way of making houses earthquake resistant because of soil liquefaction. Similarly, there are other things that one can adopt.
Thank you, sir. The next question is from Pratisha. Sir, do you think the flood problem of the Brahmaputra river basin is somehow interlinked with the earthquakes that often occur in the northeastern region?
It's a very interesting question. I have never thought on this issue, but to quickly think about it, you see what earthquakes do. They bring in changes in the topography, and if you go to the west coast of India, you can see that the sea is very shallow for almost 100 kilometers or so, no more than 15-20 meters deep. And even if you go in the older times, it appears that all that area was inhabited. We did some survey in Cambay, and we discovered structures which were like people living in them. And typically we found those structures at a depth of 10 or 15 meters of water. Then, if you remember, there was a 1819 earthquake in Kutch, which elevated the ground by 6 meters. So if you put, and even the 2001 earthquake elevated by 2 meters. So you put 2 and 2 together, it is one hypothesis that one major earthquake like the 1819 earthquake might have submerged the whole region by few meters. And that's why the sea got in. Now coming to the Assam region, I think it is more because of the flatness of the bed of Brahmaputra, because Brahmaputra bed is very flat and siltation is there all the time. So we also make a lot of bridges, dams. So when you make a dam on a river, the flow becomes very slow. When the flow becomes slow, it gives rise to sedimentation. And sedimentation raises the level of the bed. And then when there is no flow for many years, people start making small little huts and all those things where they should have never made. So a lot of floodplains are occupied by humans. Now what happens? There is a intense rain, too much of rain, so it's causing a flooding. At the top of it, the water is rising in your reservoir. You can't hold it, so you open gates. So when you open gates, more water comes out. So indirectly, many of the floods in Himalayan region are man-made. So we have to be careful about our anthropogenic activity because, you know, it takes a lot of time in planning and executing a project like making a dam, etc. And when these things are done, keeping the whole picture in mind, this would happen. So coming back to Brahmaputra case, I don't know exactly whether an earthquake caused it, etc. But definitely there are other anthropogenic reasons why this flooding is so uncontrollable.
Thank you, sir. The next question is from Prince Subhashish. How to find about the soil liquefaction at the time of construction? If the liquefaction occurs at the construction after building, then what we have to do?
Okay, there is a test. That is called there is a mechanical test which you do on the, you drill a small hole, and there's a test by which you keep on hammering, and by hammering you produce a effect of an earthquake, and we see whether the soil is liquefying or not, and we keep on doing it successfully into deeper layers. So wherever you are constructing a house, you can do cone penetrating test, it is called, and find out that how deep a layer where you are constructing a house is liquefiable during an earthquake. So once you determine that, you should take the foundation of your house below that. That is very doable.
Sir, if you would permit us, we would like to ask you a few more questions.
Please go ahead.
Thank you so much, sir. The next question is from Manya Jain. Sir, can many earthquakes of low intensities is a sign of bigger earthquake of high intensity? If so, why is it?
I think we discussed that earlier, that earthquakes do have foreshocks, but those foreshocks are recognized as foreshocks only after the main earthquake occurs. There are many regions where you will not have a main earthquake, you will have just small little earthquakes and main earthquake may not occur. So when this low intensity earthquake occurs, it is neither it is possible to say that it is a foreshock, nor say that it is not a foreshock. So this is both sides is difficult. Only after the main shock occurs, we try to say that it was a foreshock. And one of the reasons for not being able to do that is our lack of near source studies. Nowhere in the world we are able to study earthquakes in the immediate vicinity where it occurs. And Dr. Tiwari mentioned about the Koina project. One of the major aim of the Koina program near Pune was to drill a borehole to a 7-kilometer depth where the earthquakes are occurring and see them in near field to really see what happens in those regions. So first part is over. A 3-kilometer deep borehole has been drilled, and I hope that in near future we'll do that. But again, getting back to the question that was posed, no, as of now, it is not possible.
Sir, the next question is from Shaivi Kesari. Can earthquakes have a negative magnitude?
Yes, because it's a logarithmic scale. So, the energy release is something like 11.8 log E plus 12, something like that. So you have earthquakes of -1, -2, -3, -5, -6 magnitude. They start getting smaller and smaller. I'll just call you in a minute. Yes.
Sir, the next question is from Sneha. Tectonic movements are the only reason behind earthquake. Is it so? If there are many more, then what are they?
You see, tectonic movement gives rise to accumulation of strain. And the cause of earthquake is basically release of this strain. So when we talk of earthquakes of magnitude 3 and larger, they are mostly tectonic. When we come to very small earthquakes, they can be due to quarrying, due to oil exploitation, etc., where you disturb the strata, and then you give rise to an earthquake of magnitude 1, 1.5, 2. But when we come to 3 and above, it is tectonic.
Sir, the next question is from Bablin Kaur. Sir, is there any relationship between earthquakes and lunar eclipse?
This is again a topic which has been discussed intensely globally, and there has been no significant correlation found in lunar eclipse, solar eclipse, and sun spots. You name it, people have tried to correlate everything, but no definite correlation.
Thank you so much, sir. Now I would request Saurabh Borua, sir, to kindly give the vote of thanks.
I just want to say, I wanted to acknowledge my colleagues from NGRI, NDMA, and NEAST. The talk that a lot of help came from these people. So I wanted to say that before.
Sir, before I ask Dr. Saurabh Borua to give vote of thanks, I would like to tell all the audience that this encyclopedia that sir has made in 2011, he has made a new version of that, and the compendium, and that was a very, very huge task. And during the period of COVID, he has shown that we can do wonderful work by sitting at home, and his contribution to the science is great. On behalf of all the community in India and abroad, I thank you very much, sir, and it's really great to have you. And now I will ask Saurabh to give the vote of thanks.
Thank you.
My photograph is there.
After hearing a wonderful lecture, I was just amazingly hearing the question answer session. And this question answer session, sir was delivering so elaborately, excuse me, so elaborately with so much of enthusiastic that it has given a new dimension to the SRTP Eminent Scientist lectures. Through these lectures, all of us, including SRTP students, basically all are encouraged and enlightened. So here I take the opportunity on behalf of CSIR, CSIR NEAST, CSIR NGRI, and CSIR-SRTP team to offer a sincere vote of thanks to our honored guest, Professor Harsh Kumar Gupta, for enlightening us with the earthquake seismology in this regard. And simultaneously, I thank Professor Birendra Mohan Tiwari ji for offering his introduction to Professor Gupta. Simultaneously, all things were coined by Professor G. Narahari Sastry at CSIR NEAST with the guidance from our DG CSIR, Sri Monday, Professor Monday, along with the CSIR-SRTP team. So I am honored to convey my sincere vote of thanks on behalf of all these personalities. Once again, thank you very much.
Thank you very much.
Professor Gupta sir, and all the dear students for your kind presence. Thank you so much.
Thank you.